Good morning. Welcome to the International Space Station Flight Control Room. It's a busy day aboard the International Space Station today. I have a very special guest who knows all about that kind of work that takes
They're all
place.
busy days.
They're all busy days. I feel like I'm doing a sportscast here. As I said, we have a very special guest here with us today who knows all about those busy days aboard the International Space Station. Three-time space flyer, most recently Expedition 28 and 29, where he served as commander of the space station.
Yep.
And here he is. NASA astronaut Mike Fossum, welcome.
Hey, Amiko, it's great to be with you back on NASA TV today.
Yes, welcome as always. And we always love to have you here. So, as I mentioned, let's just get right into it because
Sure.
there's a lot of work that's going on aboard the International Space Station. Some activity took place on yesterday.
Right.
Yesterday, early morning, we had a Progress 49 that departed the space station. I know you guys received and saw cargo vehicles coming and going. So talk to me a little about what your role is on these vehicles when they come and go.
The Progress is a cargo ship that the Russians launch from Kazakhstan, from their launch facility there. The rocket itself is very much like the Soyuz rocket that we fly, but instead of the people on top, you have the cargo ship on top called Progress. And it's loaded with 1,000 pounds or so of equipment, supplies, everything from clothes, running shoes, food, to new pieces of equipment, either to install new experiments on board or just replacement parts for the care and feeding and maintaining of the space station.
Okay.
Get all that good stuff off over the course of a few weeks as you kind of go burrowing away. And of course, the best thing's right on top. They always put some fresh fruit. So you open the hatch, and very quickly you get to the fresh oranges, bananas, apples. Actually, not bananas. No, I have seen bananas. Those are a little harder.
Those are the first, I bet.
Yeah, you eat those first, and even some onions and garlic to have a little bit of fresh stuff on board. Once you get it emptied out, then it's time to start filling it back up. And so that's how we take out the trash, is to fill these kind of cargo ships up with all of the things you need to get rid of. We can't just open a hatch and throw it out. We use these cargo ships, and the Progress cargo ship burns up on its way back into the atmosphere, and so you pretty much incinerate everything.
Okay, great. I think we're looking at video now from this morning. I mean, not this morning, but yesterday morning's departure from the International Space Station. The Progress backs away, fires its thruster, and backed away to a safe distance. It actually has not deorbited yet. I understand Progress 49 they're going to be doing some radar system testing.
Right.
For over the next few days, I believe on the 21st, beginning on the 21st, and then on the 26th we'll deorbit, and it'll
You bet. The view we have right now is a little confusing because that's actually the view from the Progress. It has a camera that looks at the station, and that's used particularly for the docking, but also for the undocking. And so the view that we had there was of the space station as the Progress is backing away.
Okay.
So it's kind of cool.
Yeah, I think even from that camera view, sometimes when we're seeing the docking or the undocking, you can actually see the crosshairs of where they're lining up
when
of
you
the
get in
docking
close,
mechanism.
you can see that. So.
Okay. Great. And so let's talk about a few other of the cargo ships and also just the importance of those cargo supply ships.
Right.
So what other cargo supply ships do we have?
Well, the ATV, it's a Russian it's a European-built cargo ship that we've had several on board. The next one's due in a month or so. I've actually lost track of exactly when that's due. It's a very large ship that comes up again with a large amount of supplies and a large capacity for hauling things away. And we have the SpaceX Dragon.
Yep.
We've had several of those dock, and what makes the Dragon unique is that the Dragon spaceship actually re-enters using a heat shield and is recovered. And so that's our way right now of getting the largest amount of things back to the Earth. And so we're returning some of the scientific experiments that we're doing on board require us to prepare samples, whether it's biologic samples from humans, or materials samples from things we process in furnaces and stuff like that. And so now with the SpaceX Dragon, we can get those samples back to Earth. The other cargo ship is the HTV, which is a Japanese-built cargo ship, and it works pretty much the same as the Progress and the ATV. I know the acronyms get confusing. So it burns up on the way in. And we're very close. Orbital Sciences Corporation is very close to launching their first rocket tomorrow afternoon at about 4 o'clock Central Time.
Yep.
We're all waiting with a great anticipation for that event, and they're close to launching their first Cygnus resupply ship to the station also. So there's quite a number of different ships and options that we have.
And and very important, obviously, to talk about the capabilities of those vehicles and the cargo craft that's coming. Let's talk a little about the capability of the space station itself.
Sure.
I think the number one is science on space station. And today, there's been a lot of, actually all week, there's been a lot of activity on science experiments, one of which Tom Marshburn has been working on with most of the day, and one that you are familiar with. These are those bowling ball sized satellites. There are 3 different color orbs.
No, spheres.
Spheres.
And I apologize, I don't remember the acronym. We just know it as spheres, and they are
large. It's a long
large.
one.
They're
Synchronize, position, hold, engage, reorient.
Oh, very
right?
good. They're large. They're about the size, actually a little bigger than a bowling ball. They're about the size of a basketball, and it's a cooperative effort. And these spheres, they're actually, we call them satellites, and they can maneuver inside the station, not throughout the whole station. They require kind of a positioning system, and we have to set these sensors up inside the module, and we usually use the Japanese laboratory. And then the individual satellites can determine their location. They can determine the location of the other free-flying satellites, and they can do things like maneuver around each other. It's actually kind of strange once you get these things set up, and there's a lot of work to get them set up. They use just CO2, carbon dioxide, little thrusters, just compressed gas to maneuver around. But as you turn them loose, get them activated, and they come up and they go through different kinds of maneuvers, and they're we use it as a tool for, I mean, it's hardcore science, but it's also used by students, and they have student competitions where they program them to do certain maneuvers, and then they're evaluated based on how precise the students were able to direct the satellites to do the maneuvers. What a cool project for students to work on.
It looks cool, it sounds cool. It'd be great as a person here on Earth being able to see my project up there on space station and you guys working with it.
Absolutely.
Moving right along, because we have a lot to talk about here. So Cassidy was working earlier with the combustion integrated rack, and just explain what that facility is and what it serves.
Well, we have several different combustion facilities on board. The combustion integrated rack has a burn chamber, a combustion chamber down inside the rack, where we use different fuels, and we can actually control the atmosphere that's in the combustion chamber. And we're looking very detailed physics of the flame of combustion, with a lot of sensors peering through these special quartz glass windows to gather information about that, because things burn differently in zero G, and without the effects of gravity, the hot air rising, then we can study what's called the boundary equations for flame, and you're really getting into the chemistry and the physics as they all come together to try to understand the borders, right at the edge of combustibility. Will it burn? Will it not burn? What are the physics? What are the optics? What are the signatures that it gives off when it's burning? That's in the combustion integrated rack. And they're also working in the microgravity science glove box.
I was going to ask. This is the thing that you actually see them put their hands in, and I think Cassidy was working with that one on yet another plane. Speaking of playing with fire, we're actually looking at a live view
live video right now
of another experiment known as the BASS, the burning and suppression experiment. So can you talk to me a little about this?
Well, this is looking at more, instead of the exotic fuels, this is looking at more common things, including things that we have on board the spacecraft, things that we used to build the panels out of, the clothing, and other equipment. And what we're looking at is again, we're looking at the details of the combustion, because we find in the zero gravity environment things burn differently. Now, one of the applications of this is actually, it goes into smoke detector design, because the smoke detectors that we have in our homes have all been optimized based on certain assumptions for combustion products. What does a fire give off? Because those smoke sensors don't measure the fire. They're measuring the smoke and the gases that come off of that fire and find their way to the smoke sensor or smoke detector. And so so the ones on the space station, the ones we've used in space historically have been based on Earth type of measurements for combustion products. And so we're now looking to see what the differences might be in the different kind of combustion situations. Very controlled in a glove box. We can control it very carefully.
Yeah.
To understand that better.
And obviously, for safety reasons, that has some applications not only there in space but also here on Earth. So perhaps we can find some advancements in detection and suppression of fires.
Absolutely.
As well here.
Absolutely.
Very good. Well, leading into fires is a topic of Earth Day, but this has we have several other little things that we can talk about as far as Earth and how the space station relates to Earth Day. Earth Day is a very important day for us here on Earth, obviously, and as well as aboard the International Space Station. Earth Day is coming up on the 22nd, and although here I think we tend to take the whole month as Earth Day. So first of all, talk to me a little about Earth Ops, because everybody wants to know about the photos and the pictures that you take, and they're lovely and beautiful, but why are we so interested in seeing our Earth from the International Space Station?
The value is getting humans up there to look back at the Earth from a different point of view, because you can see things differently. You can see things in perspective that you can't see necessarily when you're up close on the ground. And a good example was a couple of years ago. I was on orbit when we had a lot of fires across the United States, particularly in the state of Texas. And we could see these individual fires, and you could even name some of them, by just knowing the geography and knowing that that's Bastrop, and I recognized the Bastrop area and the fire that was there. But you also see, the plumes from these fires that are all joining together and actually flowing out across the Gulf of Mexico. And so you could see the smoke haze that was actually influencing other people. They had no idea where this haze was coming from. We could see that that's happening. You can see that very frequently in other areas too, on the continent of Africa and even in Australia, where some of these wildfires are pretty extensive, and you can see where the effects of those go 1,000 miles downwind, as you can see that. Same for dust storms. It gives you the appreciation of seeing the Earth from above and how fragile it really is. And to look at the horizon, and we think atmosphere, a little bit of stuff in the air, it's not a big deal. When you get up there and you realize you can put your arm out and the atmosphere is about half the thickness of your little finger, because you could see it. And that's, you realize that's a pretty small shell. We think of the atmosphere as being so extensive, and it's not. It's really not. It's a thin layer around this planet, and so these things always come back. And you can't just do something here and make a big difference. We all need to do it together.
Right. So this leads me to, we had asked some folks out on social media to send us their questions, and so they have a few questions for you.
Good.
And one of them relates much of what you were just talking about. This one comes to us on Facebook from Kirk. Using the ECLIS, this is the Environmental Control Life Support System, to sustain life and looking at the Earth from aboard ISS, I would be interested to hear your personal opinion about our planet's environment.
Okay. Well, and Kirk, that's a great question. On board the station, well, on the planet, we have natural systems that, take care of us in so many different ways. We have plants that give off the oxygen that we need, and at the same time, they absorb the carbon dioxide that's one of our waste products. Our water is purified. Wastes find their way in. We try to purify them, but eventually they really get purified by evaporating, collecting in clouds, coming down in rain, and then we have fresh water that gathers in rivers and lakes and that we draw from for our drinking water. So in two real simple things, those kind of systems, those processes don't work on board the space station. We'd need huge modules full of plants to absorb enough carbon dioxide and give us enough oxygen. And so we have to come up with systems that can replicate Earth's natural systems to do it in a much more, and take up a lot less space, and do it in a controlled way, in a reliable way. And so we're learning, how to do those kind of things, on board the station, with systems that do all of the above, including purifying the water, because we can't afford to drink water one time and then throw it away. We have to get it purify, separate it out, and recover as much as we can.
So living aboard the International Space Station is teaching teaching us a lot of these things that we may need to use here on Earth to help conserve.
It does give us we're learning a lot in how to, particularly the water purification area, that we can use, and it's starting to show up in disaster relief and third world countries and things like that. And really, when we talk about space station being a spaceship, and we need to do this, we're on spaceship Earth too.
Great. Well, so like I said, tons of activity happening. This Friday we have an EVA. This is a spacewalk. It's going to be a Russian spacewalk with Vinogradov and Romanenko. And can you talk to us a little about that?
It's the crew looks forward to doing the spacewalks because it's a chance to do something very challenging. And step outside and do some work. For this particular one, the biggest one is installing a new experiment, aspects of a new experiment on the outside of the Russian part of the space station. They're going to do a little maintenance, and they're going to remove a few things that are no longer needed, and quite literally throw them away, literally, by throwing them. And in a controlled way, throw them so they're going a little slower than the space station, and they'll drop out of orbit within a few weeks.
Wow.
And I've lost track now of how many spacewalks Pavel Vinogradov has.
Right.
He's very experienced space flyer and spacewalker. It's going to be fun to watch him as he teaches the new guy, the rookie.
Right. As are you. I think you know something about that. You've done 7 spacewalks, so
you bet.
with three space flights under the belt. I have a question here that came to us from Twitter. It comes from Irish Space Blog. He says, Mike, does the view of Earth from cupola differ greatly from the view during an EVA?
Wow. I think the biggest difference is even when you're in the cupola, you're up against windows. It's really cool, to be able to do that, to see the Earth, to see the horizons, because most of the windows on the space station look straight down. And as you're passing over things at 5 miles a second, as you're trying to get a photo or just appreciate the view, it's kind of coming and then it's gone. And so it happens fairly quickly. In the cupola, you can see that horizon and stuff. Outside, it can be almost overwhelming at times, because instead of looking through, panes of glass, multiple panes of glass that are inches thick, you're looking through a fishbowl, that's on your head.
Right.
And you're out there and you can see around and really see the entire space station, which you don't get the chance to see through the other windows, and see the Earth in its magnificence as it's kind of rolling by underneath you.
Well, I'm sure it's a true honor to be able to be one of the people who actually get to go and venture outside the space station. So.
Yes, it is. I mean, it is an honor. It's not all fun.
Right.
It's a lot of work, and it's a little bit scary out there, even after 7 spacewalks, about 48 hours working outside.
Well, this just brings me to one other question we received on Twitter. This one comes from Amanda Hannon. She wanted to know, is it fun to do a spacewalk, and what did you do on your EVA? Knowing that you did 7, maybe we can talk about the last one.
Okay. Well, Amanda, it's fun, but it's not all fun, and I think that's really important to understand. It's serious work. It's dangerous work. It's probably the most dangerous thing we do besides launch and landing, because there's risks associated with being outside in your own spaceship. In this case, the space suit has to collect that carbon dioxide, provide your oxygen, provide your cooling, and all those kind of things. It's mentally challenging. It's physically challenging. You train a lot for it. And so it's very personally rewarding to go out and to be able to do that. But it's also a little scary out there, so you need to hang on. You need to double, triple check those safety tethers, and make sure that you're following the procedures and you're not getting careless or too comfortable. So I say you're always a little scared. I think that's a good thing. My last spacewalk was during STS-135, the last space shuttle mission, and our job there was to take a pump module that had failed on the space station, and this is a 1,400-pound pump module. Didn't weigh that, but it still has that mass.
This was the last space shuttle spacewalk during
space shuttle mission,
during
right?
space shuttle mission. And so were you with the?
I was living on board the station, and when the Space Shuttle Atlantis came up with her crew, and then Ron Guerin and I were the expedition crew members that did the spacewalk.
Right.
We moved the pump module. It was an ammonia pump, part of the space station's cooling system that had failed a couple of years before that. We moved that and put it in the payload bay of the Space Shuttle Atlantis so they could bring it back for analysis. And we moved a new experiment, remote refueling mission. It was a Goddard experiment that was brought up in the space shuttle, and we moved that, placed it on the outside of the station, and then robotically it was moved to its position on the truss of the station, where they've been doing ongoing experiments with that Goddard payload, and it's very exciting to see them doing that.
Okay, and also real quick, this one's going to be a Russian spacewalk, and so I know that at times we use some of our U.S. equipment on their spacesuits. For their spacesuits, Hatfield was installing the lights on their Orlan suits, and Cassidy was configuring the cameras. Can you talk to me about some of what your role is if you were not on a spacewalk and it was the Russian side?
Just supporting the other crew members, and I supported a Russian spacewalk while I was up there too. We set them up, and in this case, Roman Romanenko's will be wearing a helmet camera. That's a U.S. helmet camera. Will be mounted on his suit, so we'll be able to watch him as he's working. There's several different tools that we share, and so kind of set him up. I helped the crew some with some of their fit checks and had some ideas. For helping them out. The U.S. crew members will also be kind of assisting as they close the hatches, and their airlock system works just a little differently than ours, and our guys will be supporting some of the pressure checks to make sure that the hatches, none of the hatches associated with that are leaking.
Okay.
So
very good.
It'll be an exciting day.
It will be exciting. I think it always is. I think that's about all the time that we have.
Okay.
I really appreciate you coming out. As always, it's always a pleasure. And again, that spacewalk will be happening on Friday. You can watch it here on NASA television beginning at 8:30 a.m. Central Time. Thanks so much for coming out.
Thanks, Amiko.
Thank
Always
you.
great to be here. Thanks, everybody.